Hello student, good morning. I am Dr. Ajay Kumar Sinha. Today I am going to discuss electrocardiography. Electrocardiography, popularly known as ECG or electrocardiogram. What is electrocardiograph? ECG. What is it? What is its principle? How does it works? Then I am going to discuss the principle of working of electrocardiography, also known as electrocardiogram, and in shortcut it is known as ECG. Then what is its principle? That I am going to discuss. In this electrocardiography, there is a main role of electrodes. What is electrodes? What are the electrodes? Electrode is a metallic strip. It is made up of steel, maybe in any shape, and it can allow passage of current. Means it has capacity to lose the electron or gain the electron. Electrodes are of two types. First is anode, other is cathode. One will be negatively charged, other will be positively charged. But here electrodes means that it conducts electricity. It will allow to pass the current through it. And current means here, how does current flows? That first you should understand. That is, first you can tell flow of electron. Flow of electron is called current. And second, if it is in a fluid form, means liquid or gas may be there, that is called fluid. Fluid means both in a combined way. For liquid and gas, it is called fluid. Then if it is in a liquid form, solution is there, then in the solution may be some dissolved salt. Then salts means here that cation and anion. Cation means positively charged ion, and anion means negatively charged ion. Then in a salt, two types of ions may be present. Two types of ions are present, only two types, not third type. Cation and anion means positively and negatively charged ion. Then this charge, if flow of this charge, maybe cation, maybe anion, that is also called current. Then current flowing means if only metals are there, then we can tell flow of electron. Just like in a general way, in our house current flows from wire, maybe of copper, maybe of aluminum, current flows. But in chemistry or in solution, you can tell there is a flow of charge. Flow of charge, maybe cation, maybe anion, maybe both. Then this flow of charge is also called current. Then here in electrocardiogram or electrocardiography, what happens here? It is related to current. It is related to current. And here main role is of electrodes and amplifier. First important you can say part is electrodes, and second important part is amplifier, which is present in electrocardiography. It is present. Then what happens? Now I am telling you, listen carefully. The electrodes are connected to an ECG machine, ECG, electrocardiography machine, by lead wire made up of lead. Okay, electrodes are connected to an ECG machine by lead wire. The electrical activity of the heart. Here I want to tell you very important things, that in our body, or you can tell our life is due to chemical reaction inside the body. Inside the body, many chemical reaction takes place. Many. Some reactions are very fast. Some reactions are mediocre, intermediate. Some are slow. Correct? Full of reaction. Some reactions takes place in fraction of second, in picosecond, that is a 10 to the power minus 12 second, picosecond. In that time also reaction takes place, particularly in our eye. This, you can say, this type of reaction takes place, means very fast reaction. Change will be there in very fast, in this time only, picosecond. Then everywhere in our body chemical reactions are going on, or in a simple way you can tell our life is due to various chemical reactions in our body. Then in this respect our heart also plays a big role. Then here heart condition, in heart also you can say current flows through heart also. Okay, then their activities, heart activities, we want to know. For that purpose, how we will measure this things, electrical activities in our heart, how we will measure. Then to measure that things, I am telling you how we can measure their electrical activities, means electrical activities of heart. Then the electrodes are connected to an ECG machine by lead wire. The electrical activities of the heart is then measured, interpreted and printed out. This is the main work in measurement. Again I am telling you, the electrodes are connected to an ECG machine by lead wire. The second important thing, the electrical activities of the heart is then measured, interpreted and printed out. And here again important things, no electricity is sent. No electricity is sent into the body. No electricity is sent to the body. This is very important. One should not think that current is passed. No electricity is sent into the body. Natural electrical impulses coordinate contraction of the different parts of the heart to keep the blood flowing the way it should. This point is very important. Natural electrical impulses, just like a force. Natural electrical impulses coordinates contraction of the different parts of the heart. We know that heart contracts. Then electrical impulses coordinates contraction of the different parts of the heart to keep the blood flowing the way it should. It works on the principle that a contracting muscle generate a small electric current that can be that can be detected and measured through electrodes. The main goal of electrocardiography is to obtain information regarding the heart's electrical impulse, heart electrical impulses. Correct? An electrocardiogram, it is also called electrocardiogram, ECG. An electrocardiogram, sometimes this EKG is also called EKG. Electrocardio means here direct way in many countries for the word this thing here we are telling for the CH word, just a chemistry, CH word we are using. But in many countries they will use the word K. Many countries they don't follow IUPAC. IUPAC rule they will not follow. Most of the countries of the world they follow. India follow. But many countries they are not following IUPAC rule. They will follow their rule. For the chemistry, they are using the word KEMISTRY, chemistry, not like CHE. Then in that sense, for the K, sometimes this thing say K letter they will use, and that time it is called EKG also. ECG is also called EKG. Here K means just K letter means talking about the CH or C. Here ECG we are telling. There EKG they will tell, but same things. Then I was talking about an electrocardiogram is a simple test that can be used to check heart's rhythm, means heartbeat, heart's rhythms and electrical activity. Sensor attached to the skin. Actually here sensor is also used. Then here sensor attached to the skin are used to detect the heart each time it beats, heart beats. Then this sensor attached to the skin are used to detect the electrical signal produced by our heart each time it beats. This I have told how this ECG functions or works. Here there is a main role I told you for electrodes and amplifier. I will further I will discuss. It works on the principle that a contracting muscle contracts. That contracting muscle generate a small electric current. This is the main thing. Contracting muscle generate a small electric current that can be detected and measured through electrodes. This is the main thing, that muscle generate small electric currents. Actually in our body it produces you can say volt. When volt is there means potential difference. When volt is there, then obviously it will supply the current, it will produce the current, because in our body many ions are there, salts are there, they conduct electricity, salt ions, cation and anions, and this type of liquids passes through every parts of the body. Even in nerves also it passes, but there sometimes only current electron will pass. Then here I have told you. Now here this thing's main application I am telling you. It indicates, first application, it indicates the rate and rhythms or pattern of contraction of heart. This is the first application. Okay, its application I am talking about. It indicates the rates and rhythm or pattern of contraction of heart how it is contracting. This is the first application. It indicates that things. Second, it gives a clue about the condition of heart muscle. How is our heart muscle? It will give clue. It gives a clue about the condition of heart muscles and is used to diagnose heart disorder. This condition of this thing, heart muscle, that condition is used to diagnose the heart disorder. And again, third application, that it helps to determine whether the heart is normal, enlarged, or it has certain you can say it's a certain region are damaged. It will tell about that things. It helps to determine whether the heart is normal, enlarged, or its certain regions are damaged. Then this ECG test will tell all these things. Now further I want to tell about more about the you can say ECG. It works, particularly I am giving more focus on the working principle, not in other details. Okay, it works on the principle that a contracting muscle generates a small electric current that can be detected and measured through electrodes suitably placed on the body. After that, next important point that I am talking about the process for a resting electrocardiography. For a resting electrocardiography, a person is made to lie in the resting position and electrodes are placed on arms, legs, and at 6 places on the chest over the area of the heart. The electrodes are attached to the person's skin with the help of a special jelly. Just one material is there, just neither solid nor liquid jelly form, with the help of a special jelly. Electrodes, actually after that what happens, that important things I am telling you. Electrodes pick up the current. Role of electrode, now you can see. Electrodes picks up the current and transmit them to an amplifier inside the electrocardiograph. Then electrocardiograph amplifies the current, means it will increase. Amplifies means now it will make value will come, something will come big. Okay. Then this amplifier, this electrodes picks up the current and transmit them to an amplifier inside the electrocardiograph. Then electrocardiograph amplifies the current and records them on a paper as a wave line. As a wave line, it will record just like a wave. That wave only what we know, wave, common wave. You have seen in a sea and ocean tides, that is also a form of wave. Air flows, that is also a type of wave. Light wave, sound wave, like that way. Here current is flowing. Actually hot wave also, you know, in summer this term will be used, hot wave, cold wave, like that wave. Here electrical wave is there, electrical wave, due to the current. how current is flowing, they will flow in a certain pattern. Okay, in a certain pattern it flows, this current. That I am talking here only, that this electrodes picks, main role is of electrodes only here. Electrode picks up the current and transmit them to an amplifier inside the electrocardiography or electrocardiogram. Then electrography amplifies the current and records them on a paper as a wave line, because current current it is producing, muscle is producing little current, then little current it is very difficult to study. That's why it is enlarged. It is enlarged. Current is showing in a big way. You can tell like that. Means it is amplified. Amplifier will amplify. Then this things is done. Actually, this is the main function. That is now current generated by muscle in a little quantity, that is enlarged and is studied in the form of wave, because that is in the form of wave only. That is also called wave line. That what are their wave, what is the nature of the wave, pattern of the wave, that is actually studied. That tells about the activity of hertz, activity of, you can say, electrical activities of the heart. Now after that what will happen, that in an ECG, now ECG means you are knowing electrocardiography. In an ECG a sensitive lever will be there. In an ECG a sensitive lever trace the change in a current on a moving sheet of the paper. That lever in ECG, one sensitive lever is there that trace the change, where change is going on, measure change, that trace the change in a current on a moving sheet of paper. Nowadays means a modern electrocardiograph. A modern electrocardiograph may also be connected to an oscillograph. Oscillograph, what is this? Oscillograph, an instrument that displays the current on a screen. Directly we can see all the things on a screen by the use of oscillograph. Okay. Now here this I want to tell you about the normal ECG wave. ECG report you might have seen that it will be always in the form of a wave. Okay, sometimes up, sometimes down, correct? Then what does it mean? That in a normal case I am talking about, I will not go in details, but just one should know, should have idea. For that purpose I am telling you. Normal ECG wave. A normal ECG makes a specific pattern. A normal ECG makes a specific pattern of 3 recognized waves in a cardiac cycle. Actually, many waves are of many types. Many types of waves are there. Then here in a normal ECG makes a specific pattern of 3 recognized waves in a cardiac cycle. Cycle, wherever cycle word is coming, cardiac means you know that is the heart only, related to heart. Then here cycle means some things are going in a repetition. Then in heart what is going to be in repetition? Always it same thing will happen. Then you know heartbeat, that is some process there that will be repeated every time. For that purpose cycle term is used. Then here meaning of cardiac cycle. Cardiac cycle is in the same sense. These waves are three types of main waves are there. P wave. Actually, in a spectroscopy, now you might have not studied because you are in lower classes. In higher classes, like BSc onward, BSc, MSc, you will study in details about the spectrum. Okay, then there you will know all different type of waves, also light wave in different form. Then here, just to know that different type of waves are there. Then that P wave is there, Q wave is there, R wave is there, S waves are there, T waves are there. These are the name of the waves. Different type of waves are there. Then I am telling you different type of waves. P wave. After that Q wave. After that R wave, S wave, T waves. These are the waves. Okay. Then here in related to this ECG, here three main type of waves is actually repeated, or you can say their pattern will be there, a specific pattern. That means you can tell now recognized waves. Okay, so a specific pattern of three recognizable waves in a cardiac cycle. What are that three recognizable waves? Then these waves are first P waves, second QRS wave, and third T waves. PR and other two more terms are there, three more terms are there, two more terms are there, but that will be common in these things, ECG report you will see, you will find. That is the PR interval, and second is ST segment. What does, just I will brief it, what does this means? P wave means what? In the report, if you will see, you will find P wave. Then P wave means what? It is a small upward wave that appears first. P wave means it is a small upward wave that appears first. And QRS wave, here you see, this is a QRS wave. Correct? This is a complex wave. It consists of, or it is a combination of three waves. That is a wave, Q wave, R wave, and S wave. Then together it is called QRS wave. Then here, what is the QRS wave means? It is the second wave, you can tell. It is the second wave that begins as a little downward. This is the second wave that begins as a little downward wave but continues as a large upright triangular wave and ends as downward wave. Okay, it will look like a these waves look like a triangular wave, upright triangular wave, and ends as a downward wave. Now third type of wave here I am telling you, that is the T wave. What is this T wave? It is a third small wave in the form of a dome-shaped upward deflection. Okay, it is a third small wave in the form of dome-shaped upward deflection. These three type of waves in a cardiac cycle I have told you. Now two more term I want to tell you, that is the PR interval. What is the PR interval? it represents the time. It represents actually PR interval. Interval means time only. Okay, PR interval. It represents the time required for an impulse, current impulse. Okay, it is the time required for an impulse to travel through actually there are 4 chambers. Heart has 4 chambers. Then from the you can say one chamber to the last chamber, this current has to flow. This current has to flow through beginning to last, from the first to fourth chamber. Okay, then that time actually, that is called PR interval. Okay, PR interval represents the time required for an impulse to travel through a atria, that is called this atria, AV node to reach ventricles. Okay, four chambers are there. Okay, I will tell you little things about that. Then just to think that current has to pass through all 4 chambers. Okay, now what is the ST segment? This PR, this interval I told you, that is related to time required to travel from first chamber to the last chamber. Okay, that name is given as atria, AV node, like that way. Now one more term is there, that is the ST segment. ST segment. What is ST segment? Then it is measured from the end of S to the beginning of T wave. Just simply it joins, or you can say it measures from that wave. I told you waves are there here, S wave and T wave. It is measuring between these two waves. It is measured from the end of S wave to the beginning of the T wave. Means first is the T wave, then is the S wave. Then it start measuring from S backward direction, from end of S to the beginning of the T waves. Actually, this ECG has some special use also, applications. That is it can also reveals irregularities in heart rhythms, mean heart beats, known as arrhythmia. Okay, irregular heartbeat is known as arrhythmia. That this happens actually, sometimes it happens, particularly who is a patient, heart patient, this happens. Then this you can say ECG, that it can also reveals irregularities in heart rhythms, known as arrhythmia. And also another use, that an ECG also helps to determine the location and amount of injury caused by heart attack, and later helps to assess the extent of recovery. This is the ECG is very useful in this way. Now little more things I want to tell you about these things. I have used the word that is the ventricular. I have used ventricles, which is related to that. Ventricular fibrillation. Ventricular fibrillation. I want to tell about that. Ventricular, sometimes it will be this depolarized. Okay, repolarized, depolarized, that ventriculars, that is again I am telling you that 4 chambers are there, then it is related to the last 2 chamber, okay, down. Then this ventricular fibrillation, one should know what is actually these things. Ventricular fibrillation. What is this fibrillation? Ventricular fibrillation. Actually, ventricular fibrillation is a type of irregular heart rhythm. Irregular heart rhythm. During ventricular fibrillation, the lower heart chamber contract in a very rapid way, very rapidly, and uncontrolled. This in ventricular fibrillation, this is a type of irregular heart rhythm, and during ventricular fibrillation, the lower heart chamber contract in a very rapid way and uncontrolled manner. It means heartbeat, what I am talking about, lower heart chamber contract in a very rapid manner, very rapidly it will contract, and it will be uncoordinated. It will not coordinate to the other functioning, and uncontrolled, uncoordinated manner, you can tell, uncoordinated manner. As a result, what will happen? This due to uncoordinated manner, this is a heartbeat is becoming more very fast. Then what will happen? Then here, as a result, the heart does not pump blood to the rest of the body. This is an important thing here. During fibrillation, I am talking of verticular fibrillation, the lower heart chamber contract in a very rapid and uncontrolled manner. As a result, the heart does not pump blood to the rest of the body. The heart is made of 4 chambers, 2 upper chambers, that is called atria, and lower chambers, that is called ventricles. The heart's rhythm is uncontrolled by the heart's rhythm is controlled. How it will be controlled actually in a normal situation? Then this heart rhythm is heartbeat I am talking about. The heart's rhythm is controlled by a natural pacemaker. Artificial pacemaker is also there. Many people are using, patient. But here I am talking about natural pacemaker, that is also called sinus node, N-O-D-E, sinus node. Okay, then the heart's rhythm is controlled by a natural pacemaker, also called sinus node, in the right upper chamber. Right upper chamber means now down, I told you 2 chambers are down, 2 are up. Then the right upper channel, which is also called atrium. Okay, now that is functioning as a natural pacemaker. Okay, now this sinus node as a very, very important, or you can tell this upper right, or you can say right upper chamber means atrium. It has big role, very big role. Okay, the sinus node sends electrical signals that typically start each heartbeat. Our heartbeat is due to this sinus node only. The sinus node sends electrical signals that typically start each heartbeat. Now see the role of you can say right upper chamber, that is called atrium. Then this important things I am telling you, that the heart's rhythm is controlled by a natural pacemaker, that is important things. In the right upper chamber, this I told you, that is also called sinus node. The sinus node sends electrical signal that typically start each heartbeat. Then electrical signal that you are actually measuring, that activities you are measuring, heart activities by ECG machine. Okay, thank you. I am stopping only here. Thank you.